Good morning in the another episode of Code Red. How are you guys? Hopes you are secure. And in the last episode, you have learned about cybersecurity and how do we cover different aspects. Today, this session especially is for developers, but not restricting to developers because everyone should be aware about the cybersecurity loopholes or gaps in their application. Either they are developing these applications or they are using them. So let's, without further chit chat, let's get into this. So, are you aware that we develop applications by using some source code? We develop some code, we get inspired from some code, and additionally, we uh, consume some open source libraries in our code. So 80%, more than 80% of the modern applications, they use these open source libraries. So when they use these libraries, how do we make sure that these libraries are kept updated? Because as a developer, when the fresh graduate come from out from a university and he gets a job and he's all about just I will develop this component, that function, and whatnot. But the whole software development life cycle is a big game, and no one talks about it. No one teaches them what basically are the good secure development practices, and how should they maintain the software versions. Now with CI/CD, the knowledge of DevOps and DevSecOps, people are getting aware. Like they are becoming aware that how to maintain the code, different versions of it. If doesn't work, fix it on its in your local repo and then publish it. So I'm not gonna teach you how to code. I'm just exploring the area with you, like what could be the different security gaps. So you might have heard about OWASP top 10. If not, then that is the next week we will cover in next few weeks, OWASP top 10. So OWASP is an organization, and they have listed down what are the top 10 vulnerabilities in the web applications what we face today, and which actually result into data breaches. So any of the penetration testers or software security tools, if they use the at a very bare minimum setting, they check for the top 10 vulnerabilities, OWASP top 10 or SANS top 25. So SANS is another organization which has like top 25 vulnerabilities listed. So they actually scan the tools. You go into the normal general configuration and they can scan against these vulnerabilities which are well defined. But then there is a more to that. So when application becomes vulnerable, you followed the secure development guideline. You are keeping a control on that. You did everything correct. But the moment you release application in the production, or maybe from test environment to you know uh, staging and then production, so what happens in between? Some cybersecurity researcher or some bad guy across the planet might be doing a reverse engineering on this piece of code, or all the codes you have imported in your source code as a open source code. They and it's very easier, like very practical. If I cannot get into your home because you have so many measures, then I will see what are the most common lock types people deploy. So I will just break that lock. So it's similar to that. When Security researchers or malicious guys, they are able to break some widely used uh, open source library. They find some bug in it, they find some vulnerabilities, or they can manipulate data, expose the data, and do lots of stuff using that vulnerability. Then, and if this guy, the bad actor, it keeps this information with them, then it's called zero day, because the vulnerability is known now, but to a very set of people, and it is not released for the public preview so that people or OEM or other uh, companies can secure their infrastructure from that vulnerability. So this zero day, it's like hot topic across dark web, across security community, because first and the foremost, when we talk about cybersecurity, it's running some sort of software, and software is running, importing some sort of these libraries, which in a way or so it's like equal to having a common lock companies, and they just have to uh, easier to pick these logs, standard logs. In earlier days, like 20, 25, 30 years back, we used to have a list of all the devices which are there. People were using router, network switches, and firewalls were like very less at that moment. But um, in general corporate, it was like even the systems BIOS passwords and whatnot should be even Oracle databases. So we used to had these PDF file or Word file or Excel file, which had all the default user ID and default passwords for those systems. So it was way easier to get into BIOS because we knew what the OEM keeps the default. Like for example, Oracle database, I don't know if it's still valid. There was a user, inbuilt user Scott, and the password was Tiger. Oracle user has a password Oracle. So similarly for BIOS, password was like 0000 or something like there were lots of combinations. There was a Microsoft product key. If you put all 11111, it will let you work on the system. So there were lots of bypasses, and generally these bypasses are created at development stage to frequent test the systems, or developers create their standard keys. Similarly, happens to credit cards. So there are some test credit card numbers. You can use them to test your payments or not. Uh, Coming, why I'm setting this context is that any software which is running, it is not pure play software. You must be importing some code or functions or some other libraries into it, and those libraries are basically get attacked more easily than your code yourself. And because you have a weak point now in that library, which has a zero-day attack possible on it, and it's not visible in, like, who will tell you that this library is broken now? So basically, any vulnerability which is found, there is a disclosure which is like, um, you have to do honest disclosure that this exposure has happened, or this code has this vulnerability. So all the OEMs have to disclose that and create a patch according to that immediately. Or in the meantime, the patch is not available, they need to tell their consumers or the public at large that this system is exploitable, these are the measures you can take to secure it. So the OEMs or the software vendors are supposed to be on edge all the time, and this is very hot and turbulent time at this moment, and that is why cybersecurity is a hot topic. So let's come back to the code. So for example, this vulnerability is found, what happens? So every country, or there are some databases that different people maintain, and they exchange these databases. This is called CVE database. So common vulnerabilities and exposures. So what happened? This CVE is a random unique number assigned to that vulnerability. Um, there are four letters within the reference point, which represents the years. Like same code can be exposed to different vulnerabilities. Same library can be exposed to different vulnerabilities. So you can see the year, like which year this vulnerability was available, and then what is the number of that vulnerability which is impacted. And at times it happens that this library is impacted in certain environments only, not impacted at large, like in every environment. So again, that becomes a key uh, testing area to keep testing. Now, when I said that the moment you took your application from maybe development environment to production, you did everything right. But because the library now is vulnerable, 0 day is available for that library, your code is vulnerable. So it doesn't matter the number of times you have checked it. Maybe you used there are like sonar cube or some other snake or some other methods where you test it for the security as well, but their CV database is not updated, so they cannot test it beyond that. So, as I said, first level, any security scanner will do OWASP top 10 or SANS top 25, or some other specific vulnerabilities like log4j shell or similar. So what happened? These vulnerabilities are now flooded, and this open source repositories on GitHub, because there are lots of people work on it, committed. You never know when one digit or one function which they added, or one hyphen dot comma semicolon added, it made this whole code vulnerable or breakable. So in open source format, it's difficult to find, but it's difficult if a series of people out of this public are just focusing on the security of that code. And generally that is the case, but still there are people who leave the malicious code inside this, and it is after few days, weeks, or months when this gets exposed, and this is found that this has happened, and this has so much ramifications. Now, how do you make sure that your application is secure? So what are the kind of tests we run? So first is the DAST scanner, so dynamic application security test scanner. So what DAST does is it checks your compiled application, like when it's running on web server or in another environment, so it's ready to serve the consumers. So then this scanning is the best, because it does lots of scans, SQL injection, cross-site scripting, and cross-site origin or something. There are lots of scans which can be conducted. Most common is, I think, is the SQL injection. And now as a developer, you might be aware that how do we secure our code from SQL injection. So it is all about the query. In old days, we used to keep all the SQL query and receive the parameter directly in the input field. But now we have to break that, so that no one can go and input field and put a column, put a um, uh, some special characters and make it a SQL query, break the SQL query and adds its own value in the same input field. So your SQL will treat it as one command is terminated and the other is initiated. So this is a very common type of injection, and then there are lots of stuff which can go bad even in the EXEs at the run level. You inject lots of things. You replace the memory characters. So memory leakage problem, buffer overflow runs. There are lots of attacks. Now coming back to the source code. So how do we see that application is compiled, it's running, like it's the responsibility of the people who are responsible to make it running. So they must be scanning it for all the uh, possible attack scenarios. But as a developer, when the code is within your laptop, within your system, within your repo, how do you scan it? So we are going to talk about, there is a company called Equasec, and they have made this wonderful tool called Trivi. So Trivi scans your source code for open source libraries, and it gives you a very decent reporting format, like how many libraries are vulnerable and what to do about that. We will run it in few minutes. And what Trivi also does is it just not only scans your source code, it can take the log file of your running application and it can scan it. It has the capability to scan the container image, even a virtual machine or the file system. Wherever the code is available, it downloads the latest CV database and check the vulnerabilities in all the files which are like the target. So I think it's a wonderful tool, and from today onwards, you need to start using it whenever you build a code, even the smallest possible code, so that you contribute to building the secure applications. I know you are a best developer, you do everything about the safe, secure coding practices, but checking your code is also important. So this is called SCA, Software Composition Analysis. It checks for all the dependencies, libraries, and then tells you if they are vulnerable or not. And to check your source code itself, as I said, Sonar Cube and some other Sneak and some other platforms are available. The way you code has to be tested as well, whether it's a safe way of using that method or function or the call, whatever you did in your code. So let me share my screen, and I have already downloaded the Trivi and this. But if you have not, you just go to trivi.dev. Let me share that screen as well. uh, so can I share additional one more screen? Just a sec. Yeah. So this is trivi.dev. Uh, Trivi obviously is a open source project, so anyone can use it. And basically, if you see, it says that it is an open source security scanner which finds the CV's vulnerabilities and misconfigurations across the code repositories. It can check binary artifacts, container images, clusters, and whatnot all in one tool. There are similar tools available, and Trivi helps you build SBOM, which is like software bill of material, like what your application contains basically. Like we call it BOM, bill of material, when we try to order something. There's a detail BOM comes in, so it creates your SBOM. And then there are other platforms like Black Duck and whatnot. They help you. They are like commercial tools. They help you keep your whole code and repositories healthy and build healthy environment for the applications to run. So you go to getting started. If you are on Mac, you just say brew install Trivi, or you can run directly Docker instance, or you can build at your own. So it's a fantastic way. And now let me go back and share my screen where we'll be running this uh, application, and we'll show you how to what are the common use case scenarios. So we check uh, whether Trivi is there. So Trivi is installed already, although it's a old version, but it doesn't matter. And on this machine, I have some um, Docker images available. So first of all, we will pick one image and we try to scan it for, and you can scan from any directory if it is installed on your laptop. You can call Trivi because the Trivi command worked. We check the version, and now we see which image we need to pick. So let me call Trivi, and then we say, let's see the command sequences. So there are so you there are some commands and some options available. So to check the image, you check image and the image name. You, even if its image is a tar file like archive, you can still find the archive file and scan the image inside it. FS is for file system. U dot is for like current directory, but you can scan any directory. And then you can run it in server mode and lots of other options available. So, but for today, we will just, so let's go and see how many images we have. And then we say trivi image. Um, I just have to give image ID. So let's pick this one. So it it is scanning and it says, so there's nothing. Let's find something else. What about this Postgres? Or this one. So you can give separate options as well, just to scan the vulnerabilities, just to scan the high vulnerabilities, and just to scan in the, even it can scan secret keys. By default, it is scanning everything. So now you see that we scanned one image, and you will be surprised to see when you run it on your code or your container, wherever you are running your software which you compiled today, you will be amazing to see the findings. And this is how the need for shift left is important. That means the developers are required to, you know, build the secure code and just not build, keep testing the code. So they have picked the vulnerabilities database, and it has detected 184 vulnerabilities. So, and this first is the library which was called Second was the vulnerability, the CVE number you see, it was released in 2011. I'm surprised what is it doing in this container image if it is like, and severity is low again, but it is affected, and installed version is 2.2.4, that all version. Okay, it was found that apt key in apt all versions do not correctly. So this is the URL where you can go and find more about this vulnerability and how to fix it, or how to remediate it, or how to do temporary measures if no uh, resolution is available from the OEM. Now in the bash, again, it's very high vulnerability. So there are four levels of vulnerabilities, which are like critical, high, medium, and low. Low are generally informational, so we do not pay much heed. But critical, high, and medium are to be addressed immediately. Like critical and high are like where it can break even within minute. So you see lots of it, and it says that uh, this was fixed, and this was a version, and this is the version should use. Similarly, lots of stuff. This is the library, high, and this has like one has lots of issues. It is for LDAP. So you see this mapping, and then it it creates a dependency map. And in the going forward sessions, I'll tell you more tools like this. But now let's do a quick check again. So we run Trivi FS Yeti. So Yeti is the software for cybersecurity research. So I check Yeti, and this is the example of scanning the file system. Again, it has found lots of vulnerabilities in Yeti as well. So jQuery, no, everyone uses jQuery, and then this is alarming. So in the nutshell, what uh, we are running almost out of time. So, but uh, I wanted to present this because you have to build secure code, and you have to test your code before you, and always keep it testing, because you never know when the new CV is available and your code has become exploitable. And there's no dearth of bad guys out there who are continuously trying to break your code, uh, whether you are aware of it or you are not, or you just think that I am a software developer, I have a small company, I'm just building for this local customer, who will think about it? But you are using dependencies and open source libraries, then your code is more than breakable. So this was the awareness, and I think Trivi will help you keep updated. Uh, More for these tools, more of these tips and tricks, and how to pick a better cybersecurity career. As I said in every session, C Sharp and Cyber Naveen, we are bringing this cybersecurity holistic uh, course where we teach you compliance, pen testing, cybersecurity essentials, and we make you a better professional to be, joining the workforce. So keep in touch with our team out there, and they will, give you the brochure, everything for this course. Thank you, and stay safe, stay secure. I'll catch up with you next Saturday, same time.